we are finally moving on to another objective, 62, not a PO, but it is going to be important because when you simplify answers from 62, knowing how to do that came from 61. But we're moving now to the operations involving roots, right? First we learned how to simplify them. Now we're going to learn how to add and subtract them, multiply them, divide them, solve equations with them, and everything like that. So I want you to think about roots in the context of something you already know, which is how to add and subtract fractions, and how to add and subtract terms. Because this is my whole introduction. What do you possibly have to ask about it?
Okay. Wait, when are you doing retakes again? Monday and Tuesday? Thursday?
Today and Thursday.
Oh,
Thursday.
okay, my bad.
Wait, are we having a retake day Friday?
Depends on how this week goes.
Okay.
Get through, we gotta get through.
Okay.
So, remind us all, someone who's bold, brave, believes himself, has courage. What do you need to remember when adding and subtracting fractions? What do you gotta have? James?
The bottom one has to stay the same.
Okay, you need common denominators, right? And not only that, but after you actually add the fractions, what changes and what stays the same?
The top changes, the bottom stays
The
the same.
top changes, the bottom stays the same. You only add or subtract those numerators, the denominator doesn't change. Okay? The denominator doesn't change. If you don't have common denominators, what's the way to get them?
Multiply.
You have to multiply them, okay? Multiply them to get a common one, right? You wouldn't have to multiply 5 times 10 to get 50 necessarily. You could just turn the 5 to a 10. But something must be done in order to get the common denominators you want. You cannot add fractions if the denominators are different. You have to make them the same, okay? Same thing with subtracting 8/9 minus 2/27. You'd have to make the denominators the same first, okay? If you've got terms, can we combine 4x and 10x?
Yes.
What do we get?
14.
14x. What changes, what stays the same?
The number stays the same.
The coefficient changes, the x
Stays the
stay
same.
the same. Because remember what a coefficient does. A coefficient tells us how many of something we have. We have 4 x's, we're getting 10 more x's. Total, that's 14 x's. Okay? Can we combine 12n minus 7n?
Yeah.
Yeah, we have 12 n's, we lose 7. How many n's do we have left? 5. Okay? What changes, what stays the same? The coefficient changes, the variable stays the same. We have to have like terms to be able to do this stuff. The last one, 6x plus 2y, can we combine those?
No.
No. Can we do anything to allow us to combine them?
No.
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 This is in the simplest form. We are done. So sometimes, like with fractions, we can do stuff to make them combinable. Sometimes, like with like terms, we can't do anything. And we just leave it as is. If you combine those two concepts together, you have adding and subtracting roots. So in theory, if you know how to add and subtract fractions, you know how to combine like terms, you already know how to combine roots. For example, 3 root 5 plus 8 root 5. 3 and 8 are both coefficients, and like we saw with like terms, we have 3 root 5s, we get 8 more root 5s. How many root 5s do we have in all? 11. What changes? The coefficient. What stays the same? The root 5. We're done. Seriously. Okay? This is one of those times when the math appears to be a little bit easier than it seems, but it's drawing back on other concepts.
What do you do when there's a 10, but the other one's a 13?
The next one. 12 root 7 minus 9 root 7s. We have 12 of something, we lose 9 of them. How many root 7s do we have? 3 root 7. Okay? How about the third one? 10 root 10s, we get 13 more. 23 root 10. Again, the coefficients change, the root stays the same, just like denominators and fractions, just like variables in like terms.
Do we multiply?
The next one, 5 root 2 and 6 root 6. Okay? We can't add these the way they are because the roots are different. Just like up above, we had, I don't remember, it was a 5x plus 6y maybe, something like that. We couldn't combine those because one was an x and one was a y. We can't combine these because that's a root 2, that's a root 6. The only way that you can get like roots that would enable us to combine these is by simplifying, not by multiplying by root 3.
Uh-oh.
Okay? Because unlike a fraction, when we can multiply both the numerator and the denominator by something, if we wanted to rewrite 3/5 into something with a 10, are we multiplying the fraction by 2? No, we're multiplying by 1, written as 2 over 2. If we multiply this by root 3 to get that root 6, we're actually multiplying it by root 3, not by 1. And that's going to change the value of the expression. So the only way to get those like roots to be able to combine them with addition and subtraction is by simplifying. Can we simplify root 2 or root 6?
Yeah.
Yes.
No.
We can simplify 6.
How?
By 3 divided by 3. Oh.
Are there 3 and 2 perfect squares?
No.
The reason why CO61 took us 2 weeks to do is because there's a lot you have to know how to simplify. The only way to simplify a root would be to break that up into 2 factors, one being a perfect square. 6 is not simplifiable. So this would be our answer. Nothing that we can do here.
Cool. Let's go.
Okay?
Let's go.
The last one, even with variables. We have 11 root x's, we lose 2 of them. How many root x's do we have? 9. What changes? The coefficient.
Nope.
What stays the same?
Nothing.
The root.
So for the next one, we simplify.
Okay?
Good job, James. This makes my brain hurt.
Where are you getting stuck?
I'm not stuck.
Oh, just makes your brain hurt. Gotcha. Anyone unsure about what's going on up here and have a question to ask now? Because it's not going to get any easier.
Wait, really?
Really. This is your intro, your
So
basic level.
when you get another 4 and then another 4, do we just combine them?
What?
What?
Okay.
4 plus 4 is 8, James.
That's a screw.
Here we go. 5 root 2 plus 4 root 8. Are the roots the same?
Oh no, it's
No.
No. Can they be added as they're written?
No.
No. The only way to get the roots the same is by simplifying. Can we simplify root 2 or root 8?
No.
How can we simplify the root 8?
4 times 2.
So we have 5 times root 2 plus 4, and we're going to rewrite the root 8 as root 4 times root 2. Because we have to have that perfect square factor. This is why we simplify, so we can do stuff like this. We can do operations with roots. The 5 root 2 doesn't change. The root 4 becomes a 2. And the root 2 doesn't change.
Oh, you multiply. Okay.
The reason why we want that perfect square is so that we can take the root of that number, right? The root 4 becomes the 2. Nothing else in the expression changes. Everything else is exactly the same except that root 4 becomes a 2. So now we have 5 times root 2, which is 5 root 2, plus 4 times 2 times root 2, and 4 times 2 is 8. So we have 5 root 2's plus 8 more root 2's. How many root 2's do we have in all?
13.
13 root 2.
Look how smart I am.
And that would be our final answer. Okay?
What do you do for the next one?
Questions on that one?
And the 808 crush.
Questions on that one? The only thing that we did was we simplified that root 8 to be root 4 times root 2. Right? And that allowed us to get those like roots to be able to add them. The next one, 15 root 11 minus 12. Are the roots the same?
No, wait, no.
Can we just tack on a root 11 here to make it the same?
No.
No.
I wish.
Because we're not multiplying by 1. If we did that, we'd be just throwing a root 11 and for no apparent reason at all. It can't be done. Can we do anything here?
No.
No. That's your final answer.
Ooh, chocolate.
Okay, next one.
Okay.
Tell me.
10 root 50 minus 13 root 18. Definitely not the same roots there, but let's get to simplifying. How can we simplify root 50?
25 times 2.
So 10 times the root of 25 times the root of 2. get that perfect square factor. Wouldn't want to use 5 and 10. Neither of them are perfect squares, but 25 is. How can we simplify the root of 18?
9 times 2.
Do we like what we see here?
The 2 and
Yes.
the 2.
The root 2 and the root 2 are going to be like roots when we're all done breaking this thing down.
What if you don't get anything?
If you don't get like roots after after simplifying, then there's nothing you do. Okay? So we have root 25, which is 5, times root 2. And we have root 9, which is 3, times root 2. So again, the only thing that's changed is the root 25 became a 5, the root 9 became a 3. So 10 times 5 times root 2 is 50. Root 2, 13 times 3 is 39. Root 2,
And then you combine it and you get 89.
You got 11.
subtract them.
Oops, subtraction.
50 minus 39
Damn it.
is 11 root 2.
James edition.
Okay?
My bad. I thought.
If you're not showing work, it is difficult to keep track of all this stuff because you have the breaking apart of the root, you have taking the perfect square of one of those roots, you have putting it all back together, you have combining it, multi-step stuff here. Okay? The rules for addition and subtraction are just harder than multiplication and division because you have all these like things that need to happen. Questions on this stuff?
Not really. Comments, concerns?
Not quite there yet. All right. Next page. You get to look at. Oh my.
What?
Oh boy.
What?
I'll do one from each row. Which one should we do from the top row?
20 plus what?
Emmett.
20 plus 45.
Okay.
I need help with that one.
Root 20 plus root 45. And then raise your hand. He was the only hand in the air.
Yeah, guys.
Root 20.
I'm the one participating. That's all.
We're not going to get to the bottom row if we don't get to the top one. Yes. No, Emmett already picked the first one. Root 20 plus root 45. Okay, we're going to start by breaking these apart. Get that perfect square factor. Root 4 times root 5. Root 9 times root 5. Do we like what we see here?
Yeah.
Yes.
5 root 5. That's it.
Good job, James.
So the root 4 becomes a 2.
What?
The root 9 becomes a 3.
6 root 5.
6 root 5, I have more shot than
Where do you get 6 root 5?
James accepts his loss.
5 root 5. James was
You were
correct.
right the first time.
Oh, I added.
No, I said. No.
Why did you pick the Because nobody else has hand up.
Emmett, Hayden. Like I said, if you remember
Easier to make.
fractions or combining those like terms, those coefficients are what change. The roots do not. The only way to get those like roots is by simplifying. That's the difference. Yes, Ellen.
Are we going on to the next one?
Yes. Which one would you like from the second row?
428.
The last one. Okay.
So easy.
7.
Again, we're only going to get to the hard stuff at the very end if we get through this stuff first. We got 11 minutes left. The more you interrupt, the less we'll get to do together. So 4 root 28 plus 9 root 63 plus root 700. We'll start with the root 28. What are our factors here?
4 and 7.
4 and 7. So 4 times root 4 times root 7. What are my factors for root 63? 8. 9 and 7. So 9 times root 9 times root 7. And what do we get for root 700? What are my factors here? 107. So root 100 times the root of 7. Do we like what we see here?
Indeed.
Right, we can see this root 7 appear frequently. That's going to be our end root, the ones we can actually combine. But now going through this, we have 4. The root of 4 is 2 times root 7 plus 9. Root of 9 is 3 times root 7. And the root of 100 is 10
45.
times root 7.
So 45 so.
Why does it gotta be so long? Because you're in a sophomore level course. And so we can do this.
Wait, this is high school credit class.
Yes, this is a high school credit course.
No, don't.
So 4 times 2 is 8 root 7.
Wait, do I actually get credits?
Only letting you get through the lesson, otherwise nothing. 9 times 3 is 27 root 7, and then 10 root 7 at the end. When you add roots, coefficients change, roots do not. 45 root 7
2 times in a row.
is our answer.
Good job.
Good job, James.
I can get the back of that button.
Not the MCU button for that, no. Aiden.
There's MC. Can I get the last row?
Yes, we'll make sure everyone's got the notes here. Everyone good?
Indeed.
Okay. Third row, before we get to the last row, third row, we introduce variables here. Priya?
Third one.
The third one, 20xy root x minus 5 root x cubed y squared. Emmett, I really need you to do this. Okay. Anything we can do with the 20xy root x?
Yeah, you can go for it.
But is the 20 under a root? No, right? We're looking at the roots specifically. We can't simplify 20xy because that's just a value. It's not being rooted. The root x, like we've talked about before, is not a perfect square. So there's nothing we can do with the first one. The second one, 5 root x cubed y squared. Aiden?
Oh. I like the next one.
Well, we'll get to that one after we do this one.
Okay.
Yeah, go over. You go.
Doesn't the x cubed become like root x, or like x times root x or something?
Yeah, so the root of x cubed, if we break this up into its variables and its coefficients separately, the root of x cubed, we have a chart for this that can go on a help sheet. So if you're struggling. Oh, one of my 7th graders phone. If you look back at your chart for this, put it on a help sheet, this can be helpful. No, it's a phone over there. I'm not gonna, just not right now. I wanna get to this.
No, you gotta go and
This
answer
one,
it.
right here.
You go and answer it. You mean
Not right. I'm trying to get you the information to make this easier for your homework. I'm servicing you right now. So we have 5 times the root of x cubed times root y squared. The root of x cubed becomes x root x, as Hugo said. And the root of y squared becomes y. And like we did with variables before, hold on. Yes, we're putting everything outside of the root together. And so at the end, we get this 20xy root x expression, and then minus 5 xy root x.
Oh yeah, the root x.
Okay? Not only do we need the root x in each of them to match up, but we also need this xy in front of the root to match up.
Whoa.
Wow.
Right? Because 20xy and negative 5xy can only be combined if they both have an xy, going back to that like term stuff. As roots, they can only be combined if they have the same root, which is the root x. Do you see now why I'm trying to walk you through all of these as quickly as we can? The guy goes up to it. So, what does this expression end up being here? We have 20 xy root x's. We take away 5 xy root x's. How many xy root x's do we have left, Priya?
15.
15 xy root x's.
Okay, yeah, that makes sense.
Okay? Now I got it.
Answer it.
Do not answer.
Well, I'm not going to say
Please,
one.
yeah.
FaceTime him, whoever it is.
That's what I said.
Wait, when did you get it?
FaceTime.
Been here the whole time.
Hey guys, didn't know.
Who is it?
Who keeps their like credit card in the back of their phone?
Me.
I
I keep money in the back of my
Have you guys ever seen the way like a dog will look at a puzzle it doesn't understand?
Yeah.
What? What was that? This story altogether.
Call them back.
Is that
Call
Dan
them
Trainer?
back.
I know. All right. Finally, the last row where we introduce not only roots, but we have roots as part of fractions. Everything that you've seen up to this point is algebra. This bottom part is where you dip into algebra 2 a little bit. Okay. So one like this The bottom row will not be on the test. I'm just exposing you to it. It's part of your homework though, so I'm gonna do it. What will be in your test is everything up above. Okay? The last row, Aiden, you've been waiting oh so patiently. What would you like?
I like the third one.
The third one?
Four,
Sure.
four.
Please.
I asked Aiden, he said the third.
You, Aiden. Let yourself make yourself.
Emily, I already shushed you.
Oh, sorry.
Stay shushed. So 3x over the root of x cubed plus 4 over root x. The fact that we're dealing with fractions, what do we have to keep in mind needs to be the same here? The denominators have to be the same, and roots have to be the same, and any like terms that we combine, their variables have to be the same. Okay, kind of all three things potentially at play here. So the only thing we can simplify is the root of x cubed. Everything else is either in simplest form or not a root. What is the root of x cubed?
X times x cubed. Root of x.
X root x. So we can rewrite this to be 3x over x root x plus 4 over root x. The only thing that we changed was the denominator of the first fraction, nothing else. Okay? And I look at my denominators. Can I combine those? X root x plus root x?
No,
Why not?
because there's the extra x.
Even though the roots are the same, because they're part of fractions, the denominators are not. Okay? So, what can we do? Hugo.
You can multiply the x over x.
We could multiply the second fraction by x over x, because that's multiplying by
Or
1.
divide by x.
And that'll give us x root x in both fractions. That's one option. What's another option that's a little bit more efficient here? Hugo?
You can divide by x over x.
We can cancel out
Oh.
the x and the x in the numerator and the denominator of the first fraction.
Very much a sense with this one.
That's going to leave us with 3 over root x plus 4 over root x.
7 over 7 root x.
Our roots are the same, our denominators are the same. We go back to the rules for adding and subtracting fractions. The numerators change, the denominator does not. 7 over root x would be our final answer.
Yay!
Okay?
Can I do one more on the bottom row? Yeah, can we do the fourth one?
The fourth one I'll get you started.
Let's do the first as well.
What I would do is I would look at what can I simplify vertically. You got that 3 root 6 over the root of 30. What can you simplify vertically there?
What? Wait, 3 root 6?
Oh, sorry, 2 root 6. 2 root 6 over root 30. What can we simplify vertically, or how can we?
Nothing.
Evelyn? Yeah, the root 6 and root 30 are both underneath a root. Therefore, they can be simplified. Kind of we cancel out the x's here once they're outside the root. That's going to leave you with, if you think about the fraction 6/30ths would be 1/5. Root 6 over root 30 is going to be the root of 1 over the root of 5. I said 1/6, 5. Okay? So in our numerator, everything cancels out, which is awesome, because 6/30ths becomes 1/5. In our denominator, we get that root 5.
What?
Really what it looks like is this. 2 root 1 over root 5, because 6/30ths becomes 1/5. We don't write the root 1 because we don't have to. In our second fraction, we've got 3 over root 20. And if you start to think about now simplifying that root 20, what are you going to end up with when you do?
4/5.
2 times root 5.
When you simplify that root 20, you're going to get a root 5 in the denominator here that you can then eventually use to combine them. Okay? If we didn't have so many interruptions, we could have finished this out, but instead it just becomes homework. So the rest of the page is homework for tomorrow. That is how you math.
Forget to like